Okay, good morning, students. Am I audible? Just confirm that first. If any one of you can confirm whether I'm audible or not.
Yes, sir, you are audible.
Okay, thank you. Okay. Uh, again, in the previous day, we had studied about the various aspects of data and signals. Today we will continue with that. We will continue how the data is actually transferred from one computer to another computer using the physical layer, using the data link layer, and the network layer. So we will be focused on that in today's class. Okay. So first and foremost, we need to understand that whenever we are sending data from one computer to another, so obviously we will be using a communication channel, right? And a communication channel generally is an optical fiber, or it's a coaxial cable, or it's a twisted pair cable that can carry one signal at any moment of time. So obviously, if there are more than one computers, it becomes very difficult for the transmission medium to carry signals from all the computers to all the computers, right? So at a time, a communication channel can carry one signal at a time. Okay, so this results in wastage of bandwidth. Okay, and however, we can overcome this drawback by using techniques called as multiplexing. Now there are various types of multiplexing, and what are these things we will understand in the later half of the slide. Okay, so by using the multiplexing technique, what we can do is we can easily send multiple signals simultaneously over a communication channel. So obviously, in our practical life, since various computers are connected to one communication channel, so obviously it is very much essential that we have a technique in which all the computers can share this transmission channel to send data, right? Okay, so this as I said earlier, that we can achieve this thing using something called as multiplexing. Now what is multiplexing? Multiplexing is a technique which combines multiple signals into one signal. Okay, so obviously in your analog circuit classes, you must have heard of the term multiplexer and demultiplexer. So obviously we can understand that what's the function of a multiplexer, or what is the function of multiplexing. What it does is it takes two or three signals. Suppose there are three computers, so it will send three signals. So it will take three signals and it will just combine them into one signal, right? And whenever this one signal we need to disintegrate them, so what we will do, we will use something called as a demultiplexing technique. Okay, now how do we do this, we will see in the next slide. So okay, so multiplexing is also sometimes it is commonly referred as what, muxing. Okay, so the multiplexing techniques divide the communication channel into several logical sub-channels. Okay, now how do we do this, we will see in the later half of the slide. And each logical sub-channel is dedicated to an individual signal. Okay, so suppose there are three computers which want to send data to to some point that is on the opposite side of the communication channel. So this communication channel, with the help of multiplexing, can be broken down into 3 sub channels. Okay, and all these 3 computers can send data through these 3 sub channels, right? And this results in reduced wastage of bandwidth. Okay, so obviously, as I said earlier, that each logical sub channel is dedicated to an individual signal, and thus the multiple signals are sent simultaneously over a shared communication medium. Okay, so multiplexing has been used for many years in long distance telephony. Also, multiplexing is done by using a special device called as a multiplexer or a MUX, and the multiplexer combines n input lines to generate one output line. So what are the meaning of these points? We will see. We will see specifically in whenever we will study the multiplexing techniques. Okay. So just before moving on, we need to understand that multiplexing can be mainly classified into 2 types. So first one is for the analog signals, and that is known as analog multiplexing. And generally, analog multiplexing has two types. One is known as frequency division multiplexing, and one is known as wavelength division multiplexing, right? And secondly, we have a digital multiplexing, and in digital multiplexing we have only one type, that is time division multiplexing. And generally, time division multiplexing can be again broken down into 2 more parts, that is known as what? Synchronous time division multiplexing and asynchronous time division multiplexing. Okay. Now, what do we mean by analog multiplexing? So the process of combining multiple analog signals into one signal is called analog multiplexing. So it multiplexes the analog signals according to their frequency or wavelength. So if it is multiplexing according to frequency, it is known as what? Frequency division multiplexing. And it is and if it is multiplexing with respect to the wavelength, it is known as wavelength division multiplexing. So FDM and WT. Okay. So as we studied earlier, that these are the two parts of analog multiplexing. Now, multiplexing requires that multiple signals can be kept apart, right? So that they do not overlap with each other. And how do we do this? We do this using something called as a guard band. Okay, if you remember that whenever we were studying synchronous communication, we had gaps between the packets. So similarly, in this case also, so whenever, suppose if there are 3 computers which want to share a communication channel, so using multiplexing, what we can do is we can just divide the communication channel into 3 parts, right? And based on frequency or based on wavelength, and in between these 3 sub channels there will be some difference, right? And what is the difference? Difference is actually known as what? Guard band. So what is actually what exactly is this thing? We will see in the later half of the slide. Okay. And obviously, as we discussed earlier, that there are 2 types of analog multiplexing: frequency division and wavelength division multiplexing. Okay. So first and foremost, we should understand what is frequency division multiplexing. Now, obviously, if you take the example of FM radio, right? Now, what happens in FM radio? So generally, there are various stations that are generating music or generating some talk over a certain period of time, right? And what happens is, generally we have a band between for example 89 point something to 107 point something. So if this is the wavelength, or this is the suppose the what can I say, suppose the communication medium through which we will send the data. So what happens is, so suppose for example some radio channel 91.2 for example wants to send some data to a recipient, and at the same time, for example 98.5 also wants to send the data, right? At the same time, suppose for example 101.2 FM also wants to send the data, right? So what happens is, if I go to this diagram, and if you see in the sender part, so suppose we can see that there are 3 senders that want to send the data at the same time, right? Now obviously there is one communication channel only, and that ranges from 88 point something to 107 point something, right? Now obviously, how do all the stations simultaneously send the data through this channel, right? If it would have been a normal channel, what would have happened is, only one station could have sent the data, and the other stations would have been waited before the first station complete sending the data. But in this case, what we can do is we can use a multiplexer. In using this multiplexer, what we can do is we can just divide this channel into 3 parts, and that will be based on the frequency, right? So if I say that if this is a channel and I divide the channel into 3 parts, and I say that channel 1 will just transmit the data that is based on frequency of 92.6, for example. If I say that channel 2 will, if I divide the channel into 3 channels, so sub channel 2 will send the data from, suppose for example 98.5, right? And lastly, the sub channel 3 will transmit the data from, for example, channel 101.2. okay, and these, and after so using the multiplexer, what we can do is we can just merge these signals, right? We can send the signals at the same time. How? We will divide the channel into sub channels, and again after before it reaches the receiver side, what will happen is there will be a demultiplexer that will differentiate the channel based on the frequency, differentiate the communication based on the frequency, like this. Okay, so the radio stations, for example FM stations, will have the multiplexer, and your mobile devices or your radio devices on which you listen to the songs or listen to the talks will have the what? Demultiplexer. Okay, so obviously frequency division multiplexing is the analog technique, and it is most popular. It is the most popularly used multiplexing technique that we have today. Okay, and this technique combines multiple signals into one signal, and this one signal is then transmitted over the communication channel. Okay, so each logical sub channel is separated by a unused bandwidth called the guard band that I was telling you earlier. Why do we use guard bands? Because we do not want that the signal or the data in channel 1 should merge with the data of channel 2. We do not want that the data of channel 2 should merge with the data of channel 3, right? So again, to differentiate between these channels, we will have certain unused sub channels in between these channels, and these unused sub channels are known as what? Nothing but guard bands. Okay, so using these guard bands, we prevent the overlapping of the signals. Okay, so in other words, there exists a frequency gap between two adjacent signals to prevent signal overlapping. So this is what I was saying earlier, that in between channel 1 and channel 2 there will be a unused channel, and that will help, that is called as the guard band, and that will help in to prevent the signal overlapping in between channel 1 and channel 2. Now the guard band is a narrow frequency range that separates the two signal frequencies. So that is what we have discussed earlier. Okay. Now secondly, we have something called as a WDM. Okay. Now in WDM, what happens is, for example, you can see that so in the previous scenario, in the case of frequency, what we did was we just divided the channel based on the frequency of the signals. Okay. And in this case, what we will do is we will divide the channel based on the wavelength, not the frequency. Okay. So wavelength division multiplexing is another analog technique. Okay, and it is the most important and most popular method to increase the capacity of an optical fiber. Okay, so which means in the previous scenario, whenever we were doing the frequency division multiplexing, we were not using the optical fiber, we were just using what? The twisted pair cable or the coaxial cable. But in the case whenever we are using optical fiber cables, we will obviously go for the wavelength division multiplexing, and the mux and demux in this case will just be prisms. Okay, now what is the function of a prism? Which means whenever, suppose if you see in this diagram, so suppose the transmitter 1 is actually sending us data, and that is red in color, for example. Transmitter 2 is sending a data and that is violet in color, and transmitter 3 is sending a data that is green in color. Okay, now what is the function of this mux, or what is the function of this prism? What will the prism do? It will just take the signals and it will generate. So suppose it is taking the red signal, it will just generate a red signal. If it is taking a violet signal, it will just generate a violet signal, and if it is taking a green signal, it will just generate a green signal. And what it will do is it will just divide the optical fiber into 3 parts, right? And you can see what, that the first part will actually transmit the red signal, the second channel will actually transmit the violet signal, and the third part will actually transmit the green signal. Okay, and again whenever we go to the receiver, so just before that it will be demuxed, and the specific signals will be sent to the specific receivers. Okay, so what's an example of this? So in the case of frequency division multiplexing, we saw the example of FM radio, and in this case, in this example, we can have an example of, for example, I don't think or if you may have or you may not have used CDMA mobile phones. So if you would have used CDMA mobile phones, so again we can understand that whenever we are using CDMA mobile phones, the main communication channel between the CDMA mobile phones is what? The optical fiber. Okay. And if we have one optical fiber, and again various mobile phones are trying to communicate with each other, so then they will use what? The wavelength division multiplexing. Okay. So again, the only difference is that in wavelength division multiplexing, optical signals are used instead of electrical signals. So in the case of frequency division multiplexing, we were using the electrical signals, but in the case of WDM or wavelength division multiplexing, we will actually use the optical signals. Okay. So these are the ways by which we can do multiplexing in two ways. One is the frequency division multiplexing, and second one is the wavelength division multiplexing. Okay. Next is if we come to the digital data. So again, the previous data is were for the analog signals, which means the electronic signals or the optical signals. But in this case, if I have a digital signal, so if you remember that we can convert electrical signal or optical signal into digital signals using the various line coding schemes. So again, if suppose the signal has been converted into a digital signal, and now if we want to transmit the data through a channel, and we want to divide the channel into various sub channels, so then we will use something called as a time division multiplexing. Now the concept is very much simple in the case of time division multiplexing. So what happens in this case is, so suppose for the first device that wants to send the data, there will be suppose two data and suppose we name the device as A. So we will name the data of the device A as A and A. Similarly, for the second device we have the data as B and B. For the third device we have the data as C and C, and for the fourth device we have the data as D and D, right? So and what happens in this case is, so for every data, for every channel, or for every machine and for every data that the machine has, there will be a fixed time slot that will be provided for transmitting the data. So again, you can see that for the machine A, for sending the first data, I will allocate the first time slot. So you can see that in the first time slot I am sending A, right? So again, for the second machine and for sending the first data, suppose I will allocate the time slot, the second time slot. So again, you can see that we are sending data B in the second time slot. Similarly, we will be sending data C in the third time slot and data D in the fourth time slot. Now after this happens, so these machines will be left with one more data. So again, based on, for example, in this basis, based on the first come first serve basis, for example, so again we can send the data like in time slots. So again, in the first time slot I will send the data of the first machine, second time slot data of the second machine, third time slot data of the third machine, and fourth time slot data of the fourth machine. So this is nothing but time division multiplexing. Okay. So which means for every signal that I need to send or every data that I need to send, what I will do is I will allocate a specific time slot in which the machine will send the data. Okay. Now, similarly, we have asynchronous and synchronous, and obviously we understand that whenever we are having a synchronous time division multiplexing, so which means all the data will be sent in a order. So again, you can see that if the first device has two data, A and A, the second device has one data, third device has one data, and fourth device again has two data. So again, in the first time slot, A, B, C and D will be sent, right? And the second time slot, what will happen, that the first machine will have one data left, so it will send A. The second machine does not have any data, so it will be empty. The third machine again does not have any data, it will be empty. And the fourth machine, which will be left with one data, will again send the data in its specified time slot. Okay. So this is nothing but a synchronous time division multiplexing in which the data is actually sent in order, right? But in the case of asynchronous, you can see that the data is not sent in order, right? So again, you can see that we are sending A, we are sending B, and we are sending C, right? And in frame 2 we can send D, we can send A, and we can send D, right? So it depends on the receiver side that how it will, after receiving the data, how it will organize the data, right? So the sender side will just send the data as time permits. Okay, so there will be no fixed time slots. It will just send the data as time permits. There will be time slots, but there will be no fixed time slots. Which means if machine A wants to send the data, it can send obviously it will send in the first time slot or the second time slot or the third time slot, but it is not mandatory that it will only send in the first time slot. Okay, so this is nothing but the asynchronous time division multiplexing, where the data is not sent in order. It is it depends on the receiver how it will, after receiving the data, how it will organize the data by itself. Okay. Okay. Next is a very important topic, and that is known as switching. Now, what is switching? Let us understand first. So, a network generally is a set of connected devices. Okay, and whenever we have multiple devices, what happens is that we have a problem of how to connect them to make one-to-one communication possible. Okay, so if there are multiple devices, so obviously we need to, suppose in sender side there are 4 devices, A, B, C and D, and on the receiver side suppose there are 4 devices, E, F, G and H, and suppose if I want to connect A to H, right, so it becomes really difficult to connect A to H in a one-to-one communication, right. So what happens is that one solution to make this possible is to make a point-to-point connection between each pair of devices, such as a mesh connection, mesh topology, if you remember. So what happened in the mesh topology? Every computer was connected to every computer, right. So that can be a solution. That, for example, if I want to send data from A to H, for example, so again we can obviously have a mesh topology where A and H will be connected, and A will be connected to B, C and D, as well as A will be connected to E, F, G and H, right. So every computer will be connected to each other using a mesh topology. That is one solution that we have. Or what we can do is we can use a central device like a hub, and we can form a star topology, if you remember, right. But again, these methods, however, are very impractical and wasteful when applied to very large networks. Okay, so if the network becomes large, what happens is if I just communicate all the devices using mesh topology, there will be much more communication medium that will be used, right, and that is not practical, that is not feasible, right. Similarly, if I have a hub connection or if I have a star topology, so again, as we discussed earlier, what's the disadvantage of a star topology? So if the central hub fails, the whole network will come down. Okay, and this is not practical for whenever we are talking about large networks, actual practical networks. Okay. Now again, the number and the length of links require too much infrastructure to be cost efficient, and the majority of those links will be idle most of the time. So this was the this is the problem if I use a mesh topology or if I use a star topology. Now better solution to this thing is something called as a switching. Okay. Now what is switching? Switching is the thing that the network device switch does. Okay. Now you understand what's the function of a switch. Switch will connect two networks, right, of similar characteristics. Okay. So if I have two networks and they have similar characteristics, so we will connect them through a switch. Now, without going into the further details of switch, I think you already know what's the function of a switch. You have already seen a switch in your practical classes, as well as in the first slide. In the first day, I have discussed what a switch actually does. So obviously, so better solution is is to communicate between all the machines using a switch, and this is nothing but it is known as switching. Okay. So a switch network consists of a series of interlinked nodes called as switches. Okay. So whenever we have a switched network, so obviously it will consist of various computers, as well as in between the computers there will be interconnecting devices that are known as switches. Now, switches are devices that are capable of creating temporary connections between two or more devices linked to the switch. Okay. And how do we do this? We will see in the later half of the slide. And again, in a switched network, some of these nodes are connected to the end system, which means the end systems will be other computers or telephones or can be some other devices, and in between these end devices there will be interlinking devices called as switches, right. And again, switches will be used actually for the routing purposes. Okay. So what we will see is, so if you see this diagram, you will be able to understand that these are the end devices that we have. So A to J are the end devices, and all these devices are connected to each other using nothing but switches. Okay. So obviously there are 5 switches here, and there are various end components here. Okay. So this is a switched example of a switched network that we can have for practical internetworking problems. Okay. Now again, So if I have a switched network, so there is a taxonomy for that as well. So again, switched networks can be divided into three parts. The first one is nothing but a circuit switching. The second part is nothing but packet switching networks. And again, packet switching networks can be again subdivided into two more parts that are known as what? Datagram networks and the virtual circuit networks. And lastly, we have something called as a message switching network. Now, obviously, the first two, that is the circuit switching network and the packet switching networks, what happens is these switching networks are generally used nowadays in the practical applications. The third one has been phased out in the general communication, but still it may be phased out, but still we will understand the difference between a message switching network and a packet switching and a circuit switching network. Okay. Next, we come to the first kind of switch network, that is known as nothing but the circuit switched network. Now, what happens in this is that in a circuit switched network, it consists of a set of switches connected by physical links. So, if you see this diagram, you will be able to understand that there will be a set of devices connected to switches using what? A physical links. Now, what are physical links? These are the actual communication channels that we use in our day-to-day lives. Okay. And the connection between two stations is a dedicated path made of one or more links. Now, what exactly is this? We will see in the next slide. Okay. However, each communication uses only one dedicated channel on each link. So again, what is the meaning of this? We will see in the next slide. So each link is normally divided into channels using what? FDM or TDM. So we have studied FDM and TDM, and using multiplexing, we will divide these channels into sub channels. And in circuit switching, the resources need to be reserved during the setup phase, which means whenever I want to communicate from suppose this computer A to this computer E, the link that I will follow to communicate with E. So suppose I will follow from the machine A, I will go to the switch 1. From the switch 1, suppose I will go to the switch 5. From the switch 5, I will go to switch 4, and then I will go to switch E. So this channel that we will follow will be reserved, right? Which means whenever the computer A will be sending data to computer E using this channel, the other computers will not be able to use this channel. So this channel will be reserved whenever we will be having the communication. Okay. Now, what is the advantage of this? What's the disadvantage of this? We will see in the later half of the slide. Okay. So again, before the communication begins, so there will be a setup phase, and after the communication will end, there will be a tear down phase. Now, what is a setup phase? What's the tear down phase? We will see in the next slide. Okay. So again, generally, if I have a trivial circuit switch networks, it will actually look like this. So in circuit switching, the resources need to be reserved during the setup phase. The resources remain dedicated to the entire duration of data until the tear down phase. So this is what we discussed earlier, that during the setup phase, what will happen, that if I want to send data from computer A to computer M, and if I have a dedicated path for doing that, that dedicated path will first be reserved, then the data will be transferred or data will be communicated, and after the communication happens, after it is over, this the channel that we have reserved will be again given back to the network. Okay. So again, if I take an example, that let us use circuit switching network to connect 8 telephones in a small area. So again, you can see that if I take telephone 1, it is actually connected to telephone 7. So how do we do this? So if I take telephone 1, I can see that the channel just a second, guys, there has been a power cut, so just a second, I will be back, just a second. Just hold on for a bit, just hold on for 2 to 3 minutes. Okay, so are you able to see? Okay, are you able to see? See the
Yes, sir.
yes. Okay.
Yes, sir.
Okay. Yeah. Okay. So as I was discussing that suppose we have 8 telephone lines and we want to communicate them from one telephone line to another telephone line using a circuit switch network. So you can see that the telephone 1 is actually using this circuit switching network to communicate with telephone 7. So how do we do this? So if I have a telephone 1, we will see that a communication channel is there from telephone 1 to this multiplexer, right, or to this switch, for example. And again you can see that in this switch if we have two inputs, so this is the first input, so telephone 1 has the first input. So again using this switch we will have a communication channel to another switch, and again since this was the first input, so the first output will be of telephone 1, and using this first output what I can see is I can telephone 1 is actually communicating with the telephone 7, right. So similarly we can see that telephone 2 is actually connected to telephone 5, right. Similarly we can see that telephone 3 is connected to telephone 8 and telephone 4 is connected to nothing but telephone 6. So this is an example of how a circuit switching network will actually work. Okay. Now of course the situation may change whenever new connections are made, right, which means whenever telephone 1 wants to communicate with telephone 7, it will what happened? What is happening?
What is happening?
Why did it
Why
get
did it get
stopped?
stop presenting?
Okay, just a second. Yes, I'm present.
Yes, I'm presenting. Yes. Okay.
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 Yeah. So what happens is that if telephone 1 wants to communicate with telephone 7, what happens is first and foremost this communication channel is blocked. Okay. So first and foremost this communication channel will be blocked, and no other telephone will be able to use this communication channel. Okay. So after it is blocked, then the data will be transferred, and then thus this communication channel can be released. Okay. So which means if the communication channel is released and some other computers or some other telephone lines want to communicate with each other, so this situation can change. If they are already communicating, this situation will not change. If they have stopped communicating, this situation or this connection can change. Okay. Now what exactly is this, we will again be able to understand better in the next half of the slides. Again, if I take a different example, that let us consider a circuit switch network that connects computer in two remote offices in a private company. So if in one office there are 4 computers and in the next office there are 4 computers, so we can communicate between these computers in both the offices using a circuit switched network. Okay. Now what we have here is, we can see that in the network 1, in office 1 there are 4 computers, and these 4 computers will be connected to each other using what?
Hello, excuse me, sir.
Tell me. Tell me. Hello. Hello.
Hello.
Yes, sir. You are not audible from that time, sir. That only I'm saying.
Okay. 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 Now am I audible?
Yes, sir. Now it's fine.
Okay. So what I was saying is that if I take another example of a circuit switch network, where in this case there will be 2 offices, right? So in office 1 there will be 4 computers, in office 2 there will be 4 computers, and if we want to connect between the office 1 and office 2, so again we will use a circuit switch network. So what we can see here, that in office 1 we are using a 4x8 switch. Now what is a 4x8 switch mean? It means it will have 4 inputs and it will have 8 outputs. Okay. So which means, So if to this switch I connect all the 4 computers in office 1, so they are connected to each other, connected to this switch, and from this switch there will be 4 outputs. So these are the 4 outputs and these are the 4 outputs. So again the first 4 outputs will be again taken back and connected to the same link. Why? Because we want interconnection between all these 4 computers, and the last 4 outputs will be again forwarded to a multiplexer, and we can see that using this multiplexer we can again communicate from this office to this office again. So again, if this is a 4x8 switch, so we can see that there are 4 inputs and there will be 8 outputs. So first 4 output will be given to these computers, and the next 4 output will be interconnected to all the computers. Why? Because we need interconnection between all these computers. So this is another example of how we can use circuit switching for communication between 2 offices. Okay. Now again, whenever we have a circuit switch network, so generally first and foremost we should understand that what is the delay concept in the case of a circuit switched network. So what happens is that, suppose for example, if a computer A wants to communicate with computer B, so what happens is, so we can see that there are 2 switches in between computer A and computer B. Okay. So first and foremost, whenever they want to connect, so the first and foremost step is what? The setup phase. Now in setup phase, what happens is that computer A will send a special data to computer B, right, asking that it wants to send him data. If computer B accepts the sending, so what it will do is it will send an acknowledgement. Okay. So this is nothing but the setup phase. So you can see that a data is being sent from A to B, a special data, and a special data again is sent from B to A, right, and this will confirm the setup. Okay. So after the setup is done, what will happen is we will just transfer the data. So a setup is done means what? That a communication line will be reserved for communication between A and B, right. So this communication reserved line will not change. It will not allow for other devices to communicate through this communication line, right. So which means a physical communication line is set up between A and B. So after the setup happens, we will just transfer the data. So again you can see that the data transfer will not have any delay, right. So after this has been set up, after the physical connection has been set up, there will be no delay in data transfer, and after data transfer is complete between A and B, what will happen is that B will send an acknowledgement that it has received the data, and after this acknowledgement from B is received by A, this will be disconnected, which means this will be the tiered down phase. Okay. So obviously whenever we have a circuit switch network, there will be 3 phases. First one is the setup phase, in which A and B will be actually connecting, physical connection will be there. Then there will be a data transfer phase like this, and lastly then after receiving the acknowledgement, there will be a tiered down phase. Okay. So this is the concept of a circuit switched network. Okay. Now these are some important points that we need to remember in the case of circuit switched networks. So the first point is that circuit switching actually takes place in the physical layer. Okay. So the next switchings that we will see that they will take place in other network layers, but circuit switching and specifically will take place in the physical layer. Okay. Now data transferred between 2 stations will not be packetized. So what does it mean? That whenever we are sending the data, we will not convert the data into packets. We will just send the data, which means raw data, which means zeros and ones. So if I want to transfer zeros and ones, be it either in electrical form, or be it either in optical form, or be it either in some other form, a digital form, so we can use circuit switching. Okay. So in this case, the packets will not be the data will not be converted into packets. It will just be the raw data that will be sent using circuit switching, right. And again you can understand by the examples that there will be no addressing involved in the data transfer. And obviously whenever we have data communication through the physical layer, there will be no addressing involved. So that is the scenario. Okay. Next we have something called as the datagram networks. Now what is the datagram network? Let us understand that whenever we have data communication, we need to send messages from one system to another system. So that is very obvious. So if the message is going to pass through a packet switched network, it needs to be divided into packets. So again, in the previous example, I specifically said that the data will not be packetized, but in this case, the data will be packetized. Okay. So again, if the data is packetized, so what happens is that so again in a packet switch network there will be no resource reservation. So again in the previous example, in the case of circuit switch network, we have seen that in the setup phase, what was happening, that a special packet from A to B was being sent, acknowledgement from B to A was being sent, and after this acknowledgement was sent, the physical connection was constructed between A and B, right? So, but in this case, which means actually the resource was being reserved between A and B. But in this case, in packet switch networks, what will happen, that there will be no resource reservation, right? And resources are allocated only on demand, which means on first come first serve basis. And again, since there will be no resource reservation, this may create some delay. Okay. Now, what actually, how do we communicate without reserving a resource, and how does this cause a delay? We will see in the next slide. Okay. So, in the case of a packet switch network, so from the diagram we will be able to understand that suppose computer A wants to communicate with computer X, right? So, the computer A will have some data, and obviously this data will be packetized, right? So, which means we have 4 packets here, right? So, the first packet, second packet, third packet, and the fourth packet, and the computer X wants to receive data from computer A. Okay. So, again, so we can see that these are the switches. So, there are 5 switches, right? And again we can see that first and foremost we will send the first data. So, you can see that the first data is sent through the first switch to the second switch, from the second switch to the middle switch, from the middle switch to the fourth switch, and then it will go to the computer X. Again for the packet 2, so you can see that we are sending data to the first switch, from the first switch it will go to the second switch, from the second switch it will go to the fourth switch, and from the fourth switch it will be received by the receiver. So, again we can see that the order in which the sender is sending the data is not, the order is not same in the case where the receiver is receiving the data. So, the receiver must have some mechanism to reorganize the data into its specific order. Okay. So, again we can see that whenever we are sending the data like this, or sending the packets like this, the packets are not following a specific route, right? So, which means for the first packet it will be following the from 1 to 2, for the second packet it is following 1 to 3, for the third packet it is again following from 1 to 2, for the fourth packet it is following from 1 to 5, and so on. So, the data, the packets will not, so first and foremost it will not follow a specific order, as well as it will not follow a specific route. Okay. So, again this is how a packet switched network works. Now, how this is happening, let us understand. Now, all these switches, so the switches that we have here, okay. So, the switches that we will have here will have a specific table like this. We will have a switching table, or we can call it as a routing table like this. Okay. And what will the routing table have? So, suppose this is a switch, right, and there are 4 ports like this. So, what will be the routing table have? It will have, so suppose on output port 1, on port 1 the destination address is suppose 1232, which means whenever this switch receives the data, it will understand that from port 1, so suppose a packet comes into a switch and the packet will have a specific header. Now, what is the header? The header will be nothing but the destination address. Okay. So, again you can see here that it is written that the destination address in the header of a packet in a datagram network, and it remains the same during the entire journey of the packet. So, whenever a packet comes from a machine to a switch, the packet will have a header, and what will the header contain? It will contain the destination address where it needs to go. Okay. And what will the switch have? The switch will have a routing table like this, where it will be written that from output from port number 1, what we will output? We will output that packet that will have the destination address 1232. From port number 2, what will I send? I will send that packet that will have destination address as 4150. From port number 3, what will I send? I will send that packet that will have address as 9130. Okay. So, which means if I go to the previous diagram, so whenever suppose this switch, the first switch will receive the first packet, so this packet what it will contain? It will contain a destination address, and that will be the header of this packet. Okay. And so, based on this destination address, the switch will have a routing table, and based on the routing table, the switch will be able to understand that, okay, from my port number 4, I will send the data that will contain the specific destination address. So again, from port number 2, I will send the data that will contain a specific destination address. So like this. Again, so you can see that from port number 3, I will send the data or send the packet that will have a specific destination address. So like this, based on the switching table, what happens is the switch will actually send the data to the specific link or to the specific switch or to the specific destination. Okay. Again, if I want to understand that a delay, how a delay works in the case of a packet switch network, so we can see that again, since there is no setup phase, so if you go to the previous slide like this, we have seen that there was a setup phase initially, then there was a data transfer phase, and lastly, after the data transfer was complete, there was a tear down phase, right? But in this scenario, let us understand that there is no setup phase, there is no tear down phase, there is only what? A data transfer phase, right? And what happens is that whenever, suppose we have data from A, it will go to the switch, the first switch. The first switch, based on its routing table, will send the data to the next switch. Now this following of the routing table, it needs to generate a query in the routing table. The query will be answered by the routing table, and based on that answer, it will send the data through its specific port. Now this making the query, generating the answer, and based on the answer, sending the data will take some time. And again, so we can see that after the data is received by a switch, it will take some time to figure out that on which link it should send the data, and that time is actually known as what? The waiting time of a switch. So again, after the waiting time is over, once it has figured out that I need to send data to another switch, so again it will send data to the next switch, and again the next switch again will try and figure out that on which port I need to send the next data, right? So after it has figured out, so again this will be the waiting time of the next switch, and after it has figured out, it will send the data to the port to the computer B. So again, whenever a packet comes into a switch, there will be a certain waiting time, and that waiting time will be nothing but the actual delay of a packet switched network. Okay. So again, so there is one important point that we need to understand, that switching in the internet. So actually, whenever we are using internet, so switching in the internet is actually done using the packet switch network, not the circuit switch network, and this is generally this function generally happens in the network layer. So again, we have seen that in the circuit switching, it is actually happening in the physical layer, but in the case of packet switching, it is actually happening in the network layer. Okay. In the case of circuit switching, there will be a setup phase, there will be a data transmission phase, and lastly there will be a tear down phase. In the case of packet switching, there will be no setup phase, there will be no tear down phase, there will be only the data transfer phase. Again, in the case of circuit switching, we have seen that in the switches there will be no delay, but in the case of packet switching, we have seen that in the switches there will be some delay. Okay. Again, we have seen that whenever we are using packet switching, so whenever we are using internet nowadays, generally we use packet switched networks. But suppose whenever we have telephone lines, so for example, if I give an example, that whenever we communicate through landline phones, so whenever we dial a number, after dialing the number, there will be some beep sounds that will be happening. So beep, 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 and then the connection will be actually occurring. So what is this beep sound? Beep sound is nothing but the setup phase that is happening. But this does not happen in the case of whenever we are sending packets through the internet. Okay. Next we had something else, but I guess it's already 10:18. We do not have much more time. So again, we will leave this and we will cover this in the next class. Okay. So first and foremost, what we will do is you have the IMCRP code with you. Kindly respond.
Yes, sir.
Yes. So again, your IMCRP exam is till 10:30. So I will request you to kindly go and give your IMCRP exam, because IMCRP exam is very mandatory for your attendance. Okay. Again, I will be here in the meeting till 10:30. If you are facing any problems while giving the IMCRP exam, just come back in this meeting and just tell me that you are facing the problems, and then what I can do is I can try and unlock you so that you will be able to give the exam again. Okay. So just go and finish your IMCRP exam. If you have any problems, come back and tell me.